Zombie Apocalypse.
Okay, no? Magandang araw. So, ang topic natin ngayon, no, regarding dun sa continuation, dun sa past discussion natin regarding dun sa general principle of business analysis, no, which is under basic concept method. So, this time, let us try to apply, no, kung ano yung mismong konsepto ni BCM or basic concept method, na actually derived ito from strength of materials. So, be ready to be neurorized. Okay, so ito yung given natin for today, no? Let's have a rectangular section. Ito, no? Rectangular section whose dimension is 500 mm by 800 mm. And then, of course, the tendon. So, this is what you call tendons, no? Yan. This is a tendon, okay, in parabolic profile. Marami po kasi selection para sa pag-arrange ng tendon, lalo na depende kung ano yung mismong gustong i-design na compressive force, okay? So, may tendon na parabolic, ang geometrical orientation, may straight line, merong trapezoidal, eccentrically placed or non-eccentrically placed sa kanyang edges. So, irregardless. At saka may continuous pa. Okay? Regardless of the type of tendon, it is the same analogy naman if you are going to review the stress. Now, given that the distance, no, this is actually the midsection figure, okay? At midsection, we have this beam, okay, whose eccentricity or distance from the neutral axis or CG going to CGS or the centroid location for the pre-stressing tendons is said to be 175 mm, okay? As displayed, no, E is equal to 175. Now, given these loads, no, dead load of 24.8 kN per meter, okay, live load of 11.4, pre-stressing force that is 1,950 kN, and possibly a percentage of loss of 8%, regardless of the number of years, no? Hindi na specify, but upon the analogy, it was found out that the loss of pre-stressing force is 8%. Now, we have to calculate the top and bottom stress felt by the pre-stressed concrete beam under, this is very important to identify, no? Under initial and final state, considering mid-span. Bakit nga ba usually, ang analogy ng mga analysis na ganito is more on mid-span? Kasi usually, by empirical derivation, ang pinakamalaking generated stresses is either gitna or malapit sa gitna. Lalo na kapag may continuous beam ka, hindi siya exactly sa gitna, but it can be found near the center distance. So, it can be computed by means of analogy of theory of structures, okay? So, by this, we can also say that ito kasi intriguing dito, no? Ano kaya itong dead load na to? I told you before that there are some dead loads that can be already added when doing the fabrication, no? But here, hindi naman siya na-mention, so it is best assumed that this DL is actually, or dead load is actually to be added on site, meaning for occupancy purposes. Unless specified by the problem that you have to add the dead load of this particular value during initial state or during fabrication. Okay, that would be the content of initial state. So let us find out, no, paano ba ito sinosolve using the BCM or basic concept method. Don't forget that the span is also 10 meters. Baka magtampo yan. So how do we analyze this one? So let's start with the simple concept of stress. Now, recall that in your statics, okay, assuming that this is the tension force T, okay, and as well as a compression force C. So let's say this is the neutral axis, okay. So when we try to project this force to the neutral axis, it is equivalent to a couple action as we transfer the load. So mapupunta dito yung P, yun nga lang, may generate na ikot. That is moment, no? P times, let's say, assuming this is E and PE. Kaso may plus pa na isa pa moment na ikot due to load, no? This is bending due to load. Okay? So therefore, may kinalaman dito yung yung moment due to the eccentricity and the force P, okay, bending due to the moment force M, at then syempre axial force. So therefore, combined stresses will happen. So take a look on this now. We have this main equation F with the superscript of T and B. What does the superscript of T suggest? The top stress, okay, and the small subscript of B at the bottom stress. Okay, para reminded po tayo. Kasi there can be some allocation F sub T means tension that we will try to discuss on one of my video lectures. Pag yung T is naka-superscript, we are referring to top stress or the top fiber stress. While sub B, for our nomenclature in the pre-stress concrete design video lectures, it will be a reservation of the nomenclature for the bottom stress, not the for flexural, no? So, F sub B alone means bottom. Now, I'll try to erase this a little so that it could give space for some definition on this video course material. Okay? So, what is F sub A plus F sub BP plus F sub BL? Kasi yung nakita nyo kanina, tatlo yung nagko-contribute, no? First is, of course, the due to axial F sub A. How about F sub BP? That is due to pre-stressing force as a bending, and as well as F sub BL due to the load, no, gravity load force bending. So don't forget those very important highlight of the equation. So let us take consideration the compression and tension. Okay? Before we start, let's just review. Kapag compression, anong sign po natin dyan? That is negative. Kapag tension, it is positive. Madali po magawa yung nomenclature directional. Pag papuntang kaliwa, compression. Kapag papuntang kanan, tension. Ang sign ng papuntang kaliwa, negative. Ang sign na papuntang kanan ay positive. Okay? Let me erase this one para at least to give space again to the computation that we will be doing. Okay, let's try to compute first the weight of the beam per linear meter distance. Okay, so we are aware that the weight, linear weight is unit weight times the area. Area of what? Area of the cross-section, meaning this one, okay? Area of the cross-sectional of the beam that will suffer the stress. So if this is rectangular, so the area should be only 0.5 by 0.8 if the unit is in terms of meter. Recall that the unit weight of concrete is given as 23.544 kilonewton per cubic meter, or simply by computing rho times the gravity value G, where G is 9.81 kilonewton meter per second squared, and we are using that the density of concrete as with the value of specific gravity of 2.4. So meaning 2.4 times 1,000 times 9.81 all over 1,000. That gives us 23.4544 kilonewton per cubic meter. And then finally, we will get a linear weight of 9.4176 kilonewton per meter in preparation to some portion of the calculations. Now let's start with the initial state. So we have discussed before that we are talking about initial state, the beam weight alone, unless specified by the given that sometimes the dead load can be added to the initial state, since it can be sometimes be set default as an automatic additional, or maybe the dead load can be considered as an additional load to the area where it is to be installed, okay, as for occupancy plus some installation procedures. In our video lecture, we will try to consider the default condition, if not specified, that the dead load can be found on site or on the structure during installation and after and thereafter. Kumbaga, yun na yung mapagagamitan. Okay? Now, let's talk about due to axial force. So, that is just simply P over A. Why negative? Now, notice that the force P is always compressive. So, therefore, there's no way for the compression force, for the axial force not to be compressive during pre-stress concrete design, no? So therefore, this will be always a negative sign for us, as I put a highlight on this. So it is always negative since it is always compression. Okay, but you don't forget that it is a standard of compression, the negative sign here, as we go along with our sign convention. So therefore, as force P is 1,950, and our area is about 500 mm by 800 mm. So why is there a 1,000 here? my main objective is to have a unit of megapascal. So therefore, if I convert kilonewton to newton, there's a need for us to multiply it by 1,000. So converting kilonewton to newton is a 1,000 conversion. So finally, we will have the axial stress or the stress due to axial force as negative 4.875 megapascal and then indicating that it is compression. To remind you that if we have a negative sign, it reflects to a compression. Otherwise, a positive, that is tension. Okay? Okay, so itabi lang muna natin yung sagot natin dito para hindi tayo makalimot pagka ginamitan na natin ng additions. Okay? Now, what if there's a due to precessing force bending? Okay, let me give you an idea of what is happening here to give some review. Okay? Let's say this is your beam and this is your CG. Usually, let's say if we have this particular beam and a sweep cut portion here, okay? So if we are experiencing load force P, okay? Of course, there is a subjected compression force P. The end product of the beam will behave like this. It will concave upward, okay? That is the beam deflection. So therefore, the delta is said to be positive, okay? So therefore, what's happening, if we will try to consider the shape of concavity, so this is negative bending. So which is compression is located below and tension is located above. That's why, as we accept the due to precessive force of bending, whenever the precessive force is located below, don't forget, na dito ka mag-apply ng force P, ano? Diyan. So therefore, para ang nangyari is, dito yung mga bakal, tapos dito yung force P, okay? It is located below the center of gravity or the neutral axis. So it's indicating us that this is compression and this is tension already, no? Malinaw po yan. So it jives to the illustration. Okay? So that's why we need to understand that for due to precessive force bending, the top fiber experiences tension and the bottom fiber experiences compression. So that is the best explanation that I can provide with you. So that's why due to precessing, we are aware, so sa BP represents the due to precessing force, and the flexure or the bending equation is given as MC over the I, or it can be treated as M over SX, no? Dependent on what type of shape, it can be derived further. Now, for rectangular shape, before we derived, we already derived this, and we already derived, no? Already scattered in my video lecture. So, therefore, it can be said to be 6mp over bd squared, whereas m sub b represents the moment due to pre-stressing force. 6 is just only an allocation constant as we derive it by mc over the I. So, I think you are aware of that, no, on how to do that. But sige, pakita natin kung paano nangyari. So, moment sa P, ang C kasi natin is the total height, no, D over 2. Yung D pala natin dito is representing the total height for the meantime. And the inertia is BD cube over 12. So, I think you're aware of the stronger inertia. So, pag ito umangyat, no, yung 2 bumaba, 12 over 2 is 6. And there is D cube denominator and D on the numerator. D over D cube is D squared. So, that explains the idea. So, again, the 6mp over BD squared is just only applicable for rectangular shape. Other than that, let us go back to MC over the I or the M over SX. Whereas, I stands for the inertia and S sub X is representing the sectional modulus along the stronger axis. Okay? So, where M sub P is just only the moment created by the precessing force. Kasi di ba may layo sila? Ito. Ito yung CG. Okay? So, ito yung force P. Ito yung distance E, eccentricity. Then, it will take a moment, okay, on the CG. So, that is only P times E. So, as simple as that. That's why M sub P is just P sub E. And then, we will try to substitute that in our equation. Since P is located below CG, bending is negative. Already explained why. So that's why you will, I told you earlier that whenever the moment is negative, tension is located above, compression located below. Again, for consistency of convention, if we have tension, it is positive, and we have compression, it is negative. So again, that is 6PE over BD squared, already explained earlier, because this is rectangular. Notice the shape is rectangular. Then we can avail the 6PE over BD squared. Unless specified, iba na po yung equation, iba na po yung shape, then we will go back to the original MC over the I. So, I think you should derive no for different situations. Okay? And then supplying, P precessing force is 1,950 kilonewton. Converting it again to Newton, that's why we have a factor of 1,000. E is 175 mm, no need to convert. While the base is 500 and 800 millimeter raised to 2, no need to convert since 1 Newton per millimeter squared is a unit of, again, megapascal. So therefore, we will have F sub BP or the precessing force bending with the tension above and compression below condition is 6.3984 megapascal as you calculate. Ito, paki-indicate rin po ito para hindi na po tayo nalilito. Para in-explain mo na ito po yung mga sign conventions natin. Kasi different books are using different sign conventions. Okay? So, minsan, tension nagiging compression, tension magiging positive, compression is negative sa iba. I mean, tension is negative, compression is positive. So, but again, the answer is the same. It's all about sign convention and its interpretation. So, by this video lecture, we will stick to the sign convention that I'm offering. Tension is positive, compression is negative. Now, due to self-weight bending, now observe that, of course, may beam weight, ano? Kahit wala ka pa ilalagay na dead load, hindi pwedeng maalis yung beam weight. So, the nature of the beam weight, as it is simply supported, okay, so will deflect this way. Okay, yan. Hindi man pa pwedeng mag-deflect yan pataas because of the nature of the beam weight. Okay, that is pulled towards Earth. So, therefore, the deflection is going down. And looking on the bending, it resembles positive bending where compression is located above and tension is located below. So therefore, compression is negative above and tension is located below positive. Okay? So again, this is a shape of rectangular, so we can avail the use of 6m over BD squared, whereas m is the moment found on that section. We are looking after the midspan. Okay? So we will check what is the maximum moment. So automatic maximum moment since it is found on the midspan. Okay? So I think it is already for the common knowledge. Okay? That said to be moments equal to WL squared over 8. Kasi yung moment sa gitna, okay, is said to be the maximum moment. Ngayon, pag hindi yan maximum moment, we can use theory of structures to find out the moment at the midspan of that particular span. So you have to play with your theory of structures using double integration, area moment, conjugate, higher method like slope deflection, method of consistent deformation, moment distribution method, and three moment equation, and so on. Pati mga integrable clause. Okay? So therefore, we will have 117.72 kilonewton meter. So supplying it by the equation of 6m over bd squared, you can found the value of 2.2073 megapascal with the compression above, okay, and tension below. Okay, so this would be our stress diagram when we try to convert that into a figure. So maganda sana na i-drawing ito para mas ma-understand natin ano yung nangyayari doon sa material. Now recall that our value earlier, stress at axial is negative 4.875. So top and bottom, di naman nagbago kasi yan. It is uniformly distributed. That's why this is also distributed uniformly. Kaya top and bottom, ganun din yung sagot dito, negative 4.875 of a megapascal. Okay? While P bending represents due to precessing force. So, sa top is positive, no? Kung naalala nyo, tsaka negative sa baba. And for the L bending, that represents the due to gravity load. So, negative natin is 2.2070 sa top and positive naman tayo sa ilalim. So, what we're going to do pala, no? For the top stress, ito siya. I-add nyo lang yan. So, this will compose the top. And sa bottom, ito naman. So, using the proper sign, okay, bot na lang lalagay ko. So proper sign, so negative 4.875 plus 6.3984 minus 2.2073 will give you this value. While doing the bottom, nirepresent ko na sa equation na to with the proper sign, top and bottom. So parang susundan nyo is ganito. Pagdudugtungin yung top, add nyo lang yung mga value na yan. At ito yung para sa bottom. Yan. So you will get the answers like for top, that is negative 0.6839 megapascal, and FB, bottoms, is negative 9.00662 MPa. So meaning both of them are compression. Why? The sign is negative. No tension found. Is it good? Yes. Pre-stress, hanggat mare, is zero tension or tolerable tension. Both compression is much better. So if we try to represent that into a figure, it seems that the top stress is very small and the bottom stress is medyo somewhat like large. So combined, ito yung combined stresses. So meaning this would be the picture of what will be the stress looks like. So that the bottom will experience larger stress of compression. Why is it so? Ibig sabihin po nito, masyado pang mataas yung rate ng pre-stressing force na in-apply at with the centricity value E of 175 mm. So don't forget na wala pa po itong external load. So ibig sabihin, wala pa po ibang weight, mataas po yung magiging concavity so far. If that is concavity, to be proven in our video lecture ko talaga siyang tumaas. But most likely, if we have higher higher compression below and lower compression above, so most likely the deflection will be a camber type. That is camber in nature or camber. The value will be calculated next time, no, as we move along to the deflection, no, due to cambering. So, ibig sabihin po, na-achieve po ba natin yung goal ng pre-stressing concrete beam? Yes. The main goal of the pre-stressed concrete beam is to always have a camber, a deflection that goes up. Ang tanong, finalize ba ang pagkakaroon initial state? No. Kasi the beam is always subjected for additional loading. That's why we need to investigate for final state. Now, when we try to design this, at yung sa initial state mo is nag-positive na intention mo sa baba, napakalaki. Don't expect that the beam will deflect upward. It will be most likely deflecting downward. What would be the case? So is it a good design criteria? No, it is a bad design criteria because we do not want the beam to deflect downward if we are doing pre-stress. So that is the challenge in doing the design of pre-stress concrete beam. So by now, we will try to accept that as the question is being given earlier, so to answer that, the top stress is negative 0.6839 megapascal compression, and the bottom stress is negative 9.0662 megapascal compression. Don't forget always to put what is the nature of the stress. Without this, we cannot accept the answer. Why? I don't know of what conventional sign are you using negative based on what you are learning. So, I've given you my sign convention, so therefore follow the sign convention and make sure that you are depicting what you are doing, no? So please be careful. Okay, that's why I am over iterating that negative is for compression. So don't forget to write the sign and write the nature of the stress. Okay? I think it's clear, ano? Sana naunawaan po ninyo. Para at least mas maintindihan nyo pa po kung kailan siya compression tsaka tension. So what about if this is final state? Let's take a closer look. Now, for final state, we need to address the inclusion of losses on pre-stressing force and all source of load. With respect to time, we need to understand that when the concrete ages and getting matured, of course, with respect to the material of reinforcement, same as with the pre-stress. So therefore, there are some losses already happening, and that would be a separate discussion on how to assess the pre-stressing losses. Okay. So to get the point, no, it is on how do we analyze that P sub F is equal to P quantity 1 minus percentage loss. Kasi we need to get the retained force, no? So therefore, 1950 quantity 1 minus 0.08. Don't forget that the percentage loss is 8%, so what is retained? 92% or 0.92. So that's why the final precessing force is 1,794 kilonewton. Also consider the total load during the use of concrete beam as a pre-stressing element. So sigma of all the loads. So just literally add all the loads: the beam weight, the dead load, and the live load. So you will get this 45.6176 kilonewton per meter. So again, repeating the procedure earlier, so yun nga lang, pinapalitan po natin yung P na PF. Papalitan na po ninyo. So it's already 1794. So we will have FA of negative 4.485 MPa, negative sign. Same explanation to due to pre-stressing force of bending. That's why there is tension and there is compression. Okay? Already explained. So you will get F sub BP or due to precessing force as positive, negative, top, bottom, 5.866. No? Ina-iterate ko pa, no? Also due to weight bending, or you have to consider positive bending as already is discussed earlier. So therefore, again, computing the maximum total moment, WTL squared over 8. Bakit WTL squared over 8? Kasi nagkataon, simply supported po yung beam natin. Otherwise, you have to perform the shear moment diagram to make you feel comfortable in computing the maximum moment or the moment in that specific location, other than having the mid-span condition. Pwede kasi any point of the beam. Okay? So, na-compute natin F sa BL as negative 10.6916 MPa, no, with C and T, no, sa explanation kung bakit naging top is negative and passive is bending sa baba, no? Yan, na-explain na natin kanina yan. Okay? So, by adding all of them, you will find out that the top stress is negative 9.29 and the bottom stress is 0.32. So, note that in top, it is compressive but in tension naman yung bottom. So, tingnan natin yung illustration kung ano yung magiging itsura niya. Okay, so ito po yung for axial. Okay? Ito naman po yung para sa due to bending ng pre-stressing force. At saka ito yung due to bending naman of the respect to load, no, gravity loads. So earlier we got these values, no, compression top, okay, and tension bottom. So medyo humaba-haba ito, dito medyo maliit. Ang tanong, is it acceptable? I'll try to discuss that in one of our session on how do we give the meaning of what if the tension is positive 0.32. So what's the meaning of having the value? So is it crack or uncrack or whatever it is? So let us try to consider that in the next discussion. Okay? So by this, so it is clearly identified that this will be our final combined stress diagram. So therefore, to entertain the answer of the question earlier, so top stress is negative 9.29, compression force megapascal, and for the tension stress bottom is positive 0.32 megapascal tension. Okay, before we end, no, let us have to see the comparison. In the initial state, it looks like the top stress is smaller than, no, smaller than the top stress of the final, while the bottom stress of the initial looks like more than the value of the bottom stress of the final. Why is it so? Ang naging impluensya po nito ay yung sa pagkakaroon ng losses at saka ng final state condition where you apply all the load. So meaning, malaki pong factor ang pagkakalagay ng ating load. So therefore, most likely, whenever we apply the loadings, no, with respect to the final state, it means that more tension is added. So it's very clear. More tension is added by this sense, while more compression is added at the bottom. If you're talking about from initial to final state, it is always the case. Okay? Kasi gravity load, pababa naman eh. So, is it bad or good design? Let us try to find out. So, yung 0.32 ba is acceptable? Kasi sabi natin sa pre-stress, hanggat mari walang tension. Kung may tension man dapat, acceptable. So, is this acceptable? Let us try to depict this in one of my video lecture on how do we identify if the stress is passable to NECP 2015 requirement. So, thanks for viewing. Please subscribe to my YT channel. Don't forget to hit the like and share button below. So, by tradition again, you have been neurorized. Congratulations for fulfilling the entire length of the video. So, I hope that you have learned something. And see you in our next video lecture for some new learnings to be discovered. Okay? See you in our next video lecture.